So we're going to be doing remove duplicates from sorted array 2. So this is a harder problem of the previous problem we did, which was just removing duplicates 1. So the question is, given an array of nums sorted in increasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements must be kept the same. So this time we have to make sure that we keep we don't filter every duplicate out, and instead we keep at least one pair of duplicates in the final output. The rest of the problem is same. We're trying to achieve this in constant space complexity. So we're supposed to do this in place and not supposed to use any additional data structures. And what we're supposed to return is just the index at which our list ends. So basically we have to make sure we're pointing at the final index of the final duplicate. Okay, so here I think we can just do this as kind of like the way we did it previously, but instead of checking for just one duplicate, we basically just make sure we store 2 duplicates if we see 2 duplicates, and then we have a while loop to skip the remaining duplicates. So what that would look like is we can sort of have a current index and sort of a replacement index, both initialized to 0. And the replacement index is going to point towards the index which we can write into, and the current index is going to point to the index we're currently reading and checking for duplicates on. So we have a while loop on the current index being less than length of nums. If that's true, we first store nums of replacement index. Let me just copy this. Is equal to nums of current index. And then we have to increment both of them. So replacement index plus equals 1. Current index plus equals 1. So this will always store the first time we see any particular index. But now to account for duplicates, we can have a if condition. So if current index is less than length of nums, and we see that this index is a duplicate of the previously stored element. So that would be if nums of current index is equal to nums of current index minus 1. So we saw a duplicate. We can again just store it. Okay. So now we have the first element in place. We have, if that element has a duplicate, we have the duplicate stored as well. But any additional duplicates must be filtered out. So for that, we can just have a while loop. Current index is less than length of nums, and nums of current index is equal to nums of current index minus 1. What we need to do is just skip it, right? So current index plus equals 1. And actually this while loop, if we have this while loop, we won't need this line because it's going to increment it for us. So we can get rid of this. And then the replacement index is going to be pointing towards the last element that we saw that was valid. So there we go. This code looks right. Let's give it a shot. Okay, so let's run it. Okay, there we go. Perfectly valid solution. We can analyze the space and time complexity. So for this solution, We have the space complexity of O of 1 because we're not storing any additional data structures than the ones we were given. And we're doing everything in place. So constant space complexity, the time complexity, is O of n because we're only looping through the list of n integers once. Yeah. So this while loop is gonna only like the current index is only going to point to any particular index once. So we're only looping through the whole list once. Okay, that should be it.